Hello there and welcome to the series of videos going through the content of A-Level Maths. Here we're looking at an introduction to three-dimensional vectors, so we can see how to answer questions from exercise 12b. So, a vector in three dimensions will follow the rough pattern of I, j's and k's this time. So in 2 dimensions we were just using i's and j's, but in this case in 3 dimensions we're using i's, j's and k's. An I represents a movement of 1 in the x direction, j represents a movement of 1 in the y direction, and k represents a movement of 1 in the z direction. And then you can combine these and multiply these up as you wish. So for any vector in 3 dimensions, it can be written like this: p amount of direction in z in the x direction, q amount of direction in the y dimension, and r amount of direction in the k in the z-axis. And these can be negative numbers as well, and it can always be written as a column vector as well. Personally, column vectors are my favourite way of writing a vector. Just saves a bit of ink on your pen, really. Consider the points a 1, 5, minus 2 and b 0, minus 3, 7. Let's have a look at what they want us to do. Find the position vectors of a and b in I, j and k notation. Find the vector a to b as a column vector. Okay, so column vectors were the ones that I prefer. The position vector of a point is the vector to get it from 0, 0, 0. So in this case here, O to the coordinate A is a movement 1 in the x direction, 5 in the y direction, and minus 2 in the z direction. So the point A has effectively a position coordinate of I plus 5j minus 2k. It's effectively what is the vector to get it from O to the position vector you're currently at. And OB works in exactly the same way. There's a 0 on the I component, so you don't need to write 0i, just leave it blank. And then minus 3j plus 7k. So those are the answers to A, question A here. Part B, find the vector from A to B as a column vector. Well, one way of doing this would be to just do coordinate B, take away coordinate A. You could do it in I and j and k notation if you wanted to, but it's probably easier just to do it in vector notation, or in column notation rather. So 0 minus 1 is minus 1, minus 3 minus 5 is minus 8, 7 minus minus 2 is 9. Okay, so fairly straightforward so far. There's a lot more to come in this video though. So the vector A and B are given as a movement 2 x direction, minus 3 y direction, 5 z direction, and B is the vector of 4 in x direction, minus 2 in y direction, and 0 in the z direction. And all we're looking to do in this question here is to just combine the vectors in certain ways. So 4 times the A vector, add the B vector to start with. So what we'll do is we'll quadruple all of the elements in the A vector, and then add it on to the B vector. So 12 minus 14, 20, just like that. For part II, we're going to have to double the A coordinates, triple the B coordinates, and then do 1 take away the other. So 2 times the A coordinates and 3 times the B coordinates, and then do 1 subtract the other, just like it's asking us to in the question, and we get minus 8, 0, 10. Okay, part B now is state with a reason whether either of these vectors is parallel to 4i minus 5k. Now, a way of working out whether two vectors are parallel to each other is if you do one vector times a scalar multiple, you get another vector. It doesn't seem like this is going to work with the first vector, so we need to compare the vectors. So it doesn't look like it's going to work with the first vector. This was 12 minus 14, 20. If we times this by, or if we effectively factor out a 3 to get a 4 on the I component, which is what we're looking for, then the other two components don't really match up. So when we pull out a factor to make the x component equal to the x component we're looking for, we want to see if the other components match up as well. Let's have a go at this with the other vector 2a minus 3b. That was minus 8, 0, 10. Pull out a factor of minus 2 to get the 4 on the top. And in fact, yeah, we do get a 0 and we do get a minus 5. Yeah, you can kind of do it just by spotting it as well. You can see, is this going to be parallel to 4, 0, minus 5? What's the scale factor multiple, and is there a constant scale factor multiple across all three vectors? Yes, that scale factor multiple is minus 2. Okay, so yes, there is the vector 2a minus 3b, which is parallel to 4i minus 5k, because that vector is a scalar multiple of 4i minus 5k. Okay, so we also need to be able to calculate unit vectors. Now, what a unit vector is it is a vector with a distance of 1 if you just follow that vector across. Effectively, if you were to get your measuring ruler out and measure the length of that vector, no matter which way its direction is, you will get a distance of 1. Okay, so one way of seeing how to do this is if we've got an x component of a and a y component of b, obviously the modulus of your vector is going to be square root a squared plus b squared. If we'd like this direction of the vector to be 1, ideally we want to make this a 1 length for a unit vector. We need to effectively divide all the sides by this value here. So on the bottom now it's going to become a divided by square root a squared plus b squared, and on the side here it's going to be b divided by square root of a squared plus b squared. And we can do exactly the same with this for 3 dimensions as well. So what you'll see is that the way that we're going to make a unit vector, which is represented with this type of symbol here, is by working out the magnitude of the vector and then dividing each of the x, y and z components by the magnitude of that vector. So work out the magnitude first, and in this case it's square root of 21. So to work out a unit vector, we now divide the original coordinate by the magnitude. So it's effectively 1 over root 21, 2i minus j plus 4k. Okay. Effectively, you could also write this as 2 over root 21 I minus 1 over root 21 j plus 4 over root 21 k. And if you were to work out the modulus of this value here, you would get 1. The modulus of a hat should give you 1. If you were to do 2 over root 21 squared minus 1 over root 21 squared plus 4 over root 21 squared and square rooted your answer, you should get 1. Okay, so that's what it means for a unit vector. Make sure you remember that word because it's usually something that accidentally falls through the gaps in people's revision. Okay, so unit vector, find the magnitude and then divide your original vector by that magnitude. Okay, something else here. I told you this video would be a little bit of a long one. Given that the vector a is equal to 2i minus j plus 4k with a magnitude of root 21, now that we've got it all, which is the same as the last question, calculate the angles between the x, y and the z axis. So effectively what we've got here is this direction vector a here, and we want to work out the angle between this vector here and the x-axis. The letter that we're going to use to represent this angle is a theta subscript x. And there's a formula that we can show you how to work this out. The formula goes something like this. It's going to be the x component divided by the magnitude of your vector. And then if you can see here, the right angle triangle that we've created, this is going to be a cos angle. So it's going to be cos minus 1 of x divided by modulus a. Okay, and this works for not just x's, but this will work for y, and this will work for z as well. So the formula in this case here is going to be cos divided by adjacent over hypotenuse. So in this case here, cos theta x is equal to the x component. Now what's the x component in this case? The x component is 2, so it's the value 2, divided by the modulus of the whole vector, so 2 squared plus minus 1 squared plus 4 squared, all square rooted, that was 21. So effectively the two key numbers that we're going to need here are 2 and root 21. So do 1 divided by the other and do cos inverse. And we get 64.1. So that is the angle between our vector and the x-axis. And effectively this here is the formula for it. We can do exactly the same thing with the y variable as well. So this is the formula that you'll need to work out that angle between your vector and the y-axis. You will take the y component, which is effectively minus 1, divide it by the magnitude of the whole vector, and do cos inverse. In this case we get 102.6. And very similarly for the z component as well. Whoops, it doesn't need a y on the top for z, it needs a z on the top. So in this case here, 4 is a key number, and same again, root 21 is a key number. So it's going to be z divided by the modulus of the whole vector, and then cos inverse it. So in this case here, cos theta z is equal to 4 over root 21, cos inverse it, and we get theta z, theta z equals 29.2. Okay, so those are the three formulas that you need to remember for working out the angle between your line, your direction vector line, and any of the three axes. Okay, one more question I think then. So points A and B have position vectors 4i plus 2j plus 7k, and B has the position vector 3i plus 4j minus k relative to a fixed position O. Find A, the direction A to B, and show that the angle, the triangle OAB is isosceles. Okay, so remember that isosceles triangles have at least two of the sides that are the same length. So that might be a key part of this question. So in this case here, let's draw ourselves out a diagram. We've got two position vectors here, 4, 2, 7 and 3, 4, minus 1, relative to a fixed position O. And I can see here that O is going to be one of the vertices in my triangle, so I'll include O in my diagram as well. And let's join A to B together as well. Find A to B. Okay, so the first thing to do would be to find A to B, and the way we do that is by doing B take away A. So we do 3, 4, minus 1, subtract 4, 2, 7, and we get minus 1, 2, minus 8. That's how we get from A to B. Now the next thing we're going to do here is start showing that this triangle here is isosceles in some respect. So what I'd probably do is work out all of the magnitudes on all three of the triangles here, and then just hopefully two of them will match up and equal each other. So work out the magnitude and we get root 69 on the vector from A to B, so this length here is root 69. The length on the lines from O to A are root 69. And do we need to show any more? Yeah, we'll go and show that this is root 26. So it's not an equilateral triangle. If all three sides were equal, it would be an equilateral triangle. But in this case here, it's just an isosceles triangle with OA equaling the same length as A to B. Okay. So we have two vectors of equal magnitudes, therefore the lengths of those lines are equal. Alright then, so your turn to have a go at these three questions here then. Pause the video and try this question out. Okay then, so the vector from P to Q. So the way we work out the vector from P to Q is by doing coordinate Q subtract coordinate P. So in this case here it's going to be minus 1, 3, minus 5, subtract 3, 0, 7. And in this case here we're going to get minus 4, 3, minus 12. Part B is going to be the distance between P and Q. The distance between P and Q is written like this, and it's calculated by the magnitude. So 4 squared plus 3 squared plus 12 squared. Remember, the little bit of a shortcut of doing this is you can just drop the square, the negative symbols on the negatives, because you're going to square it anyway, so there's no point in including the negatives. And this gives us 13. Part C, find a unit vector in the direction from P to Q. So remember that a unit vector is the vector divided by the modulus. So that's just, you might need to write this down because it is something that usually falls through the gaps. A unit vector is your original vector divided by the magnitude of that vector. So in this case here, the direction vector is going to be minus 4 over 13, 3 over 13, and minus 12 over 13. And this vector here, if we were to draw it out and measure it out with a ruler in 3 dimensions, we'd have a distance of 1. That's what it means to be a unit vector, units being 1. Okay, thanks very much for watching this video. Do have some practice on exercise 12b. There was a lot we covered in this video, so feel free to rewind it and check it out again. Have a go at some of the difficult questions. Make sure you persevere through the difficult ones and ask your teacher for help if you need any. Okay, thanks for watching.